Hello everyone, myself Param Joshi and let's discuss the application of cloud computing technology in metal exploration. So let's get started. Introduction. So basically what is metal exploration, right? Metal exploration is basically like extracting, exploring different metals and minerals throughout the surface of the earth. So with the development of economy, metal exploration has become more and more popular and most of the metal resources near the earth's surface has already been dried up. So the metal resources are increasingly in demand. Therefore, in order to meet the needs of social and economic development, deep exploration technique has become a major trend in metal exploration. So, as a well-developed technology, cloud computing technology is also widely used in metal exploration and has made an important contribution to the development of this industry. So, we'll be using the metal exploration using cloud computing. So here we will be discussing about these two modules, these two models in further slides. That is a map reduced programming model and an edge-based programming model. So with this approach, we will be designing up a cloud computing system that increase the efficiency for the metal exploration ratio. So let's move on. Method. So here is a map reduce method. So basically what is a map reduce programming model? Map reduce programming model is an associated implementation for processing and generating big data sets with a parallel distributed algorithm on a cluster. A map reduce program is composed of map procedure, which performs filtering and sorting, and a reduce method, which performs a summary operation. So MapReduce, first it supports high efficiency and reliability as MapReduce programming model can run the calculation process of metal exploration in the computer so as to improve the work efficiency of metal exploration. It also provides faster scheduling. The advantage of MapReduce programming model is that the scheduling process when multiple tasks are running together can run multiple tasks in metal exploration together, thus saving the huge computing resources. And it also supports multiple languages. Like this model supports wide variety of language like C, C++, Java, etc. Let's move on. Now let's talk about the non-relational database, which is HBase. So what is HBase? HBase is a distributed column-oriented database built on top of Hadoop file system. It is an open source project and is horizontally scalable. Right? HBase is a data model that is similar to Google Big Table designed to provide quick random access to huge amounts of structured data. It leverages the fault tolerance provided by Hadoop file system. So HBase basically handles very large and complex data, unstructured data. HBase basically has those two components, that is HMaster and HRegion server component. So what is that? HMaster is basically responsible for coordinating regions in the cluster and execute administrative operations, while HRegion server is responsible to handle a subset of tables data. Right? So here is the HMaster's uh, two components, that is HBase two components, that is HMaster and HRegion server. Let's move on. Implementation. So this is basically like a flow chart for this approach. So first we will be basically creating a cloud platform, right? So the cloud platform is basically that is an Hadoop plus HBase distributed mode. So first we'll be creating this cloud platform construction, which is of Hadoop plus HBase distributed mode. Then following other steps for this approach, how we will be implementing this approach. First, we need to upload some data of metal exploration to HDFS. We can also set the size of block and the number of copies, right? Once the data is uploaded to HDFS, we can view the HDFS file system on the web interface to see if the data is perfect. Then, through this map reduce programming model, the original data can be converted to H file format, which is convenient for database entry. The H file obtained from the second step is further loaded into the HBase cluster, and the program implementation in the second and third steps are both the subclass of the main class, which is called and run by the main class. The main class is mainly used to configure the running environment parameters. So this is the overall workflow of this approach. Results. So due to this programming approach using MapReduce programming model and an HBase database, the efficiency is increased. So in this, the research results show that the metal exploration efficiency in 2016, 17, 18 and 19 are increased by 3.4%, 4.2%, 5.1% and 5.9% respectively. This shows that the cloud computing technology can significantly improve the efficiency of metal exploration and can accurately explore deep geological metals and can quickly process a large number of complex unstructured data. Conclusion. Due to MapReduce programming model and the H-based non-relational database approach, the overall efficiency of the system is increased. Right? Also, by using this programming model, the scheduling process is also increased, thus saving the computing resources. Thank you.